Look at your face in a mirror right now. Flat cheeks, a small jaw, a forehead that curves up and back instead of sloping forward. You've probably never once thought of your own face as evidence of anything. But it is. It's evidence of the fastest transformation in the history of the great apes. And you're wearing it right now, without even realizing it. Here's the strange part. Chimpanzees look almost exactly like chimpanzees did millions of years ago. Gorillas look like gorillas looked millions of years ago. Slow, steady, barely changing generation after generation. But somewhere along the way, your ancestors broke that pattern completely. Their skulls didn't just change, they changed faster than any other ape skull on record. Why would evolution suddenly speed up for one single species and not the others sitting right next to it on the family tree? To understand this, you first have to understand what evolution actually is. It isn't a straight line marching towards something better. It's a slow accumulation of small changes, generation after generation, shaped by whatever helps an individual survive and reproduce in its environment. Most of the time, that process crawls. A species finds something that works, and it sticks with it for millions of years, because there's no pressure forcing anything to change. That's why sharks look roughly the same as they did tens of millions of years ago. That's why crocodiles barely changed either. Stability is the default setting of evolution. Speed is the exception. So when scientists found that the human lineage was the exception, they wanted to know exactly how big that exception was. In 2025, a team of researchers led by Dr. Aida Gomez-Robles at University College London analyzed skulls across humans and living apes studied. Their study, published in the Proceedings of the Royal Society B, measured differences in brain case shape and facial structure across species and used those differences to estimate rates of evolutionary change. The conclusion was direct. Human skulls changed more quickly than those of any other ape species studied. Not slightly faster, meaningfully, measurably faster. Think about what that skull is actually made of, structurally speaking. It's not one simple bone. It's a case built to hold something extraordinarily expensive to run. Your brain uses roughly 20% of your body's energy, despite being a small fraction of your total body weight. Building a skull that can house an organ like that, while also flattening the face and repositioning the jaw, means rewriting a huge amount of the genetic and developmental blueprint for how a head forms in the womb. That kind of rewrite doesn't happen by accident. Something had to be pushing for it. This is where the story gets genuinely strange, because there isn't one single tidy explanation. There are several forces that appear to have been pulling on the human skull all at once. The first is diet. Around 2 million years ago, early members of the genus Homo began eating differently. Meat, marrow, and eventually cooked food meant less time spent chewing tough plant fibers all day. Anthropologist Richard Wrangham at Harvard has argued for years that cooking specifically changed human anatomy, not just human culture. Cooked food is easier to digest and extract calories from. That means smaller jaw muscles, smaller teeth, and a face that no longer needs to be built like a vice. Less mechanical stress on the jaw and face over generations allowed the skull to shrink and reshape in ways that would have been impossible for an ape still cracking raw, fibrous plants all day. The second force is the brain itself, and this is where things get almost paradoxical. A bigger brain requires a bigger birth canal, or a baby born at an earlier, less developed stage. Human infants are famously helpless compared to other primates. A newborn chimpanzee can cling to its mother's fur within hours. A human newborn can't even hold up its own head. That helplessness is the price humans pay for being born with skulls small enough to fit through the pelvis, while still growing an unusually large brain after birth. Evolution had to balance brain size against the physical limits of childbirth, and that balancing act put constant pressure on skull shape for hundreds of thousands of years. The third force is arguably the strangest one, and it's social. Researchers studying human self-domestication, including work associated with anthropologist Brian Hare, have pointed out that human faces show signs of what's sometimes called domestication syndrome. That's the same set of physical changes seen in domesticated animals compared to their wild ancestors. Flatter faces, smaller brow ridges, more juvenile-looking features retained into adulthood. In domesticated foxes bred purely for tameness in the famous Russian fox experiments, researchers noticed something they weren't even trying to produce: floppy ears, curled tails, softer, more juvenile faces. Selecting for a single trait, tolerance of others, dragged along a whole cluster of physical changes as a side effect. Some researchers think something similar happened to humans, except instead of a scientist doing the selecting, it was other humans. Groups that could cooperate, read social cues, and tolerate strangers without immediately turning aggressive had an advantage. Over tens of thousands of years, if calmer, more cooperative individuals were more likely to survive and pass on their genes, that selection pressure could have quietly reshaped human faces alongside diet and brain growth without anyone choosing it on purpose. So you have three separate pressures, all operating on the same structure, all at once. Cooking softened the jaw. Childbirth constrained the skull. Cooperation flattened the face. None of these forces was working alone. They were stacking on top of each other, generation after generation, compressing what might have taken tens of millions of years in another ape lineage into a fraction of that time in yours. There's a fourth factor worth pausing on, and it's the one that ties the other three together. Brain tissue is metabolically expensive in a way almost nothing else in the body is. Every extra gram of neural tissue demands a steady, reliable supply of calories, and that demand doesn't pause for bad seasons or lean years. Paleoanthropologist Leslie Aiello, working with physiologist Peter Wheeler, proposed what's known as the expensive tissue hypothesis. Their argument was that the human gut actually shrank as the human brain grew, because a smaller, less energy-hungry digestive system freed up calories that could be redirected upward into the skull. A body can only spend so much energy at once. Something has to give. In your ancestors, it was the size of the gut. In other apes, still eating large volumes of raw, fibrous plant matter that require long digestion, that trade-off was never available. Their guts stayed big. Their brains stayed comparatively small. Your gut got smaller. Your brain got bigger. And your skull had to be completely rebuilt to hold the result. Layer that on top of cooking, birth constraints, and social selection, and you start to see why the pace of change accelerated the way it did. It wasn't one door opening. It was 4 doors opening at roughly the same time, each one pushing skull shape in a compatible direction, each one reinforcing the others. A softer diet made room for smaller jaws. Smaller jaws made room for a differently shaped face. A differently shaped face, paired with more juvenile features, made individuals seem less threatening to one another, which encouraged more cooperation. More cooperation meant better access to shared food and childcare, which meant more energy available for brain growth. And more brain growth demanded, again, a smaller gut and a reshaped skull to support it. The forces didn't just coexist, they fed each other in a loop that kept accelerating instead of settling into balance. It's worth pointing out how differently this played out in your closest living relatives. Chimpanzees and bonobos share more than 98% of their DNA with you. They use tools. They form complex social bonds. They even show basic cultural transmission, teaching each other techniques for cracking nuts or fishing termites out of a mound. But none of that was enough to trigger the same runaway acceleration in skull shape. Primatologist Jane Goodall's decades of field observation at Gombe showed just how sophisticated chimpanzee tool use and social structure can be. And yet, chimpanzee skulls today look remarkably similar to chimpanzee skulls from hundreds of thousands of years ago. Complexity alone wasn't the trigger. It was this specific, compounding combination of diet, birth constraints, energy trade-offs, and social selection, all landing on one lineage at once, that set human evolution apart from every cousin species sitting beside it on the family tree.
Here's the twist, though, and it's the part that should genuinely surprise you. Speed is usually associated with instability. Fast-changing systems tend to be fragile ones. And yet, the fastest evolving ape skull didn't lead to a fragile species. It led to the single most dominant species this planet has ever produced. The same rapid changes that reshaped your face are tied directly to the changes that let your brain support language, tool use, planning, and eventually science itself. The very instability that should have been a liability turned into the foundation of everything humans are capable of doing today.
And this is where the reframe lands. You've probably spent your whole life thinking of your face as just, well, your face. Something that looks a certain way because of your parents, your genetics, pure chance. But every flat cheek, every reduced brow ridge, every slightly shortened jaw carries the fingerprint of 3 separate evolutionary pressures competing and cooperating across hundreds of thousands of years. Your face isn't neutral. It's a record. It's the physical residue of cooking fires, difficult childbirths, and countless small acts of tolerance between strangers who decided not to fight. There's something worth sitting with here about your own life, too. You live in a species defined by rapid change, not slow stability. Where other apes settled into a shape that worked and stayed there, your ancestors kept adjusting, kept adapting, kept being reshaped by pressures they never consciously chose. In some sense, that's still true of you. You are not a finished product. You are the current version of a lineage that has never stopped changing, shaped as much by what you eat, how you're raised, and who you cooperate with, as your ancestors were shaped by fire, birth, and trust. Think about how much of your own daily life echoes these same 4 pressures, just in modern form. You still eat food that's been processed to be easier on your body, whether that's cooking, freezing, or simply buying it pre-prepared, freeing up hours and energy you don't spend chewing or digesting the way a wild ape does. You were still born helpless, dependent on caregivers for years before you could do anything for yourself, exactly like every human infant before you. You still rely on cooperation with people you barely know, strangers on a train, co-workers in an office, neighbors down the street, trusting that most of them won't turn on you. And your brain still consumes a wildly disproportionate share of your daily energy, quietly working in the background every time you plan, worry, remember, or imagine. None of these pressures disappeared. They just changed shape. The same forces that rebuilt your ancestors' skulls over hundreds of thousands of years are still quietly present in how you live today, just operating on a different time scale, in a different world. You're not separate from that ancient process. You're the most recent draft of it. And maybe that's the real lesson buried in your own bone structure. Evolution didn't hand your species a finished design and then step back. It kept pushing, kept testing, kept layering new pressures onto the same skeleton, right up until this exact moment. Every version of you, from your great-great-grandparents to the child you might have someday, is still part of that same unfinished experiment. So the next time you glance at your reflection, you're not just looking at your own face. You're looking at the fastest changing skull in the history of the great apes. Every flat cheek and every gentle brow line is proof that your ancestors didn't just survive their environment. They were rewritten by it, faster than any ape before them. And somehow, that speed is exactly what made you possible. If this changed the way you look at your own face, that's worth sharing. Hit like, drop your thoughts in the comments, and subscribe if you want more of your own history explained like this.